plus Boeing 767, Cpat, pneumatics, cooling, and heating. The 767 has two packs powered by engine bleed air, APU bleed air, or ground air. The pack control selector has an auto mode and a standby mode, which sends a signal to the respective pack flow control valve and shutoff valve. The normal position is auto. On the passenger aircraft, there are 4 temperature control zones. Pack controller regulates temperature for the coldest zone, and then trim air is added to adjust temperature for the other zones. The zones are Zone 1 is the flight deck, Zone 2 is the forward cabin, Zone 3 is the mid cabin, and Zone 4 is the aft cabin. The 300 Special Freighter has no mid cabin zone. On zones 2 through 4, so all but the flight deck, the temperature is displayed in the cockpit. No temperature for the flight deck, only the trim air valve position. Standby mode is a manual control mode. Pack switches are used to reset the packs if there's a fault. If the pack off light is illuminated, then the pack valve is closed. This could be the result of the pack being selected off, a trip having occurred in the pack, or no air to the pack. The in-op light indicates that the output temperature is too high or there's been an overtemp in the pack, or a failure of the automatic controller. In this instance, it does not necessarily mean that the pack will shut down. Both packs have a high flow mode, which increases the output flow when signaled by the controller. This occurs when the opposite pack is off or in op, one recirculating fan is off or in op, or in ground operations when the APU or ground air is supplying air for the pack. The high flow position is inhibited when the wing anti-ice is on and only one engine is supplying bleed air, or an engine is inoperative, or aft cargo compartment fire switch is on. Flight deck contains foot and shoulder heaters for both pilots. They are electrically operated and function only in flight. There are 3 cabin temperature controllers which allow the temperature to be selected between the coldest setting of 65 degrees Fahrenheit and the warm setting of 85 degrees Fahrenheit. Packs are controlled to maintain the coldest setting, and trim air, which is provided by bleed air, is added to the other compartments as required. The trim air switch, when on, trim air is used to maintain selected temperatures. When off, packs attempt to maintain all compartments at an average temperature approximately 75 degrees. Turning the zone control off turns off trim air for that zone, and the in-op light for that zone illuminates. The in-op light can indicate that the switch is off, that there's a duct overheat, there is a fault in the controller, or the trim air is off. If utilizing ground air conditioning, there is no temperature control on the aircraft. The air conditioning temperature is controlled by the air conditioning cart on the ground. Conditioned air from packs mixes with air from the 2 recirc fans in the mix manifold. The recirc fans maintain overall cabin air circulation, permitting the packs to be operated at reduced flow. The left fan is forward of the E&E cooling system, and it draws air from the flight deck and the forward E&E compartment to the mix manifold, and it runs continuously on the ground. The right fan draws air from the aft cabin. The left and right recirc fan switches control the operation of the recirc fans. If the switch indicates on and in op, then there is a failure of the fans and will have an associated ICAS recirc fan message. If a fan is off due to switch position or failure, The respective flak will switch to high flow. For equipment cooling on the ground before engines start with a temperature less than 45 degrees Fahrenheit, the equipment cooling recirculates inside air for cooling. Both the inboard supply valve and the skin heat exchanger valves are open and both fans operate, the supply and the exhaust fan. On the ground with temperature greater than 45 degrees Fahrenheit before engine start, the inboard supply valve and the overboard exhaust valve are open. The skin heat exchanger valve is closed. The inside cooling air is used to cool the equipment and it exhausts overboard. After both engines start, the skin heat exchanger valve opens, the inboard supply and the overboard exhaust close, and air is circulated through the skin heat exchanger, allowing the aircraft to pressurize with both fans operating. Once in the air, only the exhaust fan operates. The supply will open if the exhaust fan fails. Controls are on the overhead panel and indicate failures. There is a smoke detector in the equipment compartment, which will indicate smoke detected in the compartment. If in override and reverse flow is not detected after 1 minute, that's all wrong. Hold on. A valve light illuminates after 30 seconds. Pressurization may not operate due to the overboard exhaust valve not being closed. Cargo heating. There are 3 control switches which control shutoff valves. The aft and bulk cargo is supplied from the body pneumatic duct, and the forward cargo is supplied from the center pneumatic duct. With switches on, downstream control valves maintain cargo temperature above 45 degrees Fahrenheit. In the event of an overheat, which is greater than 90 degrees Fahrenheit, the overheat light and ICAS forward, aft, or bulk cargo overheat message occurs. The associated shutoff valve closes automatically and conditions automatically reset. If the control valve fails open, the system will most likely cycle on and off around 90 degrees. The bulk cargo heat selector on the accessory panel in normal operates as described above with no cabin ventilation. In the vent position, the fan circulates cabin air to the compartment and maintains at least 65 degrees Fahrenheit. This is the preferred location and position with live cargo aboard. Pressurization. The outflow valves are on the lower left tail area. There are 2 and stop. Okay, we'll keep going. There are 2 automatic controllers which utilize barometric pressure, air ground position, throttle position, and cabin pressure to control. The outflow valves are driven by AC motors or DC motors. AC motors in automatic control and DC motors in manual control. Negative pressure doors and positive pressure relief valves protect against excessive differential pressures. In auto mode, the landing elevation is set and it references the captain's altimeter to determine cabin pressure. The auto rate normally is set to the index mark, which provides 500 foot per minute climb and 300 foot per minute descent. When the throttles are advanced on takeoff, the outflow valves flow slightly to produce a small differential pressure. At 35,000 feet, max differential pressure is approximately 8.6 plus or minus 0.1 psi. Pressurization system enters cruise mode when level for 1 minute. It will select the grader of scheduled altitude or landing field elevation. It remains in cruise until the aircraft climbs greater than 500 feet when it goes into climb mode, or descends greater than 1,000 feet, which will place it in descent mode. In descent mode, the cabin will descend to landing altitude minus 100 feet to ensure a positive differential pressure on landing. After landing, the controller opens the outflow valves at a controlled rate and conducts a self-test. Failure of the selected autocontroller causes switching to occur. There's no indication of the failure or the switch to the other controller. There is a status prompt on the lower ICAS that alerts the crew. If both controllers fail, the auto in-lop light and ICAS cabin auto op light will illuminate. Manual is selected, and the controller can be used to select climb or descend to open or close the outflow valves. If the cabin altitude is 10,000 feet or greater, the cabin altitude light on the pressure panel will illuminate as well as the cabin air light. Master warning siren will sound, and the message will remain until the cabin descends back below 8,500 feet. In automatic, if the cabin is greater than 11,000 feet, an aneroid switch closes the outflow valves. Pneumatic. Engine bleed, APU bleed, or external compressed high pressure air can be used to provide air conditioning, wing and engine anti-ice, engine start, center hydraulic air driven pump, and hydraulic reservoir pressurization. The connectors for ground pneumatic air attach to the left duct. Two connectors are recommended for use during an aircraft start on the ground. Each duct has an isolation valve. They are normally, when the engine power is running, the left and right isolation valves are closed and the center isolation valve is opened. On the ground, with the engines off, all three isolation valves are normally open. Both engines provide low pressure or high pressure air. High pressure air is used at low power settings. Bleed valves can be turned on and off to provide air to the manifold. They're electrically controlled and pneumatically operated. Bleed switches are normally on with the flow bar displayed. Before engine start, bleed switches are selected on. The flow bar will indicate and the off light will illuminate. The off light will remain until after engine start when there is demand for bleed air. The engine anti-ice does not require the bleed valve to be open. The wing anti-ice does require the respective bleed valve to be open or the opposite bleed valve and the isolation valve. APU bleed is used on the ground for air conditioning and engine start. It can provide bleed air up to 17,000 feet. It provides air through the center manifold and the APU bleed valve. The APU bleed valve will illuminate while in transit, indicating that the valve and the position disagree. After engine start, the APU bleed valve depends on system logic. With one engine running, the APU bleed remains open. Two engines running, it normally closes. With engine anti-ice on, APU bleed pressure may be higher than the engines, and the engine bleed valve may remain closed. Concludes 767 Cpat review of Pax Pneumatics Cooling and Heating.